So, Marvel asked me to make a real replica Herbie for the red carpet premiere of the new Fantastic Four movie. And in like 7 days and a lot of help from some friends, I was actually able to make it happen. Oh yeah, did I happen to mention he works? Here's how I did it. You're overacting again. Hey guys, what's up? Welcome back to the channel. My name's Frank, and I am so excited to make this video finally. You guys have been seeing it on my Instagram, and obviously you saw in the intro of the video, I got to make a real animatronic working Herbie for the Fantastic Four premiere. And it was the coolest but hardest thing I have ever built. So, why did I even get the opportunity to do that? Well, let's do a little bit of time traveling. Back in December, me and 4 other content creators were invited to London, to the Pinewood Studios, where they were filming Fantastic Four. We got to go there on day like 60 out of 80 something of principal photography and see the set. Now, I can't show you my footage quite yet. It hasn't been released by Disney and Marvel. There's certain steps that need to go through it, and it just means I can get this video out to you quicker. However, some of the other content creators like Shay and Ashley who are there have videos up on Instagram, so you're gonna see some clips from there. You'll even see some cameos from me, but we got to go see the Fantastic Car. We got to go this really cool practical prop. We got to go see Reed's lab, this huge set they built. Probably my favorite part was actually inside the Excelsior ship. It was just the coolest thing I think I've ever been inside, and the fact that they just built this real, well, not real, but it was incredible. I will never live that down, and I cannot wait to show you guys more photos of that eventually. And then obviously we got to see the real working animatronic Herbie, the one they built for the movie that was fully puppeteered. It was controlled by 5 different people at the same time. You had somebody rolling it around and actually controlling it, making it sway and dance, turning its head, moving its eyes. They even had this arm rig on one of the guys that as he would move his arms back and forth, Herbie would then mimic it, because it's harder to do that with joysticks when you can just link it up to a person. That was really cool to see. And part of the deal with Disney and Marvel was, hey, we'll bring you to the studio, you film content, you kind of share and promote the experience, and that the new Fantastic Four movie's coming out, and eventually we'll bring you to the red carpet premiere, or blue carpet premiere in this case. Can you build something to bring? Now, obviously after seeing Herbie working in real life, well, that was my thing to bring. Immediately I'm like, I need to make a Herbie. I had no idea how I was gonna do it, and you know what? It was December, the premiere was in July. It was a problem for later. Now, time went on, I had other projects pop up, and we were getting closer to the premiere in July. Marvel reached back out, hey, we're gonna start working on getting you out. It was time to actually start building this thing and getting it ready for the premiere, and I had like 10 days. So initially I wanted to keep this as simple as possible, make a little statue that drove around in an RC car, but after seeing the real life Herbie and seeing how much it moved, I wanted to do what I could to bring this thing to life. And for that, I really needed an engineer. Who do I know?
Huh?
Luckily, I know one.
Is this some kind of sick joke?
Well, she didn't answer. Who else do I know who's a good engineer? It doesn't actually need to be a real engineer. It could just be somebody who's really good at making animatronics or building things and designing. Kiera.
Bruh.
Hello, darkness, my old friend.
Hello.
Hey, you can you help me with a project?
Yeah, Nick's here too.
Oh, hey Nick.
Hello.
Hi. I have to build this Herbie animatronic for Marvel in like 7 days. You guys can help me with that, right?
Do you even know what a servo is, Frank? I thought all you knew how to do was push a button on your printer.
7 days?
Yeah.
I don't even...
You can do it. Come on. You got this.
I mean, if you want me to fly out there and like spoon feed it to you, maybe.
Lose my number. Okay, so Kiera's a no-go. Who else do I know who's built Iron Man suits, can engineer things, has also made a Mark 85, a really good Mark 85. Talon. Well, Talon's out. Want to help me build a robot?
Sure.
Okay, now that I have an engineer's life properly threatened and on payroll, I need the 3D files. Well, luckily there were a few out there, so I started to take a look. Unfortunately, the first files I saw were actually from Yosh Studios, where it is a very cute model, but it's more of a statue. It's not meant to be modded and cut up and have internals. You kind of just print it, and there is some articulation, and that's fine. Unfortunately, the other thing I noticed is that it is kind of inaccurate with some of the details, especially the back. Now, again, I have perfect reference photos from the Pinewood one in the movie, so I want the model we're making to be as perfect as possible. So unfortunately, while cute, Yoshi's were out. Next up was Dio3Ds, and honestly, Dio3Ds were pretty good right off the rip, but again, I just didn't know how well these were gonna play with having to fit things in the model and getting things changed. I needed on-the-spot iterations and changes, and while Danny is a good engineer, he's not a 3D modeler, I needed a good communication. And my other concern was getting that live feedback. If I needed something changed immediately, unfortunately, going through DMs and emails with Dio3D, I just didn't have that time. So that brought me into Nikko Industries DMs, and I hit him up and I'm like, hey man, this is the plan, this is the project, can you do it? Next thing I knew, me, Danny, Nikko, and 2 of his modelers were in a group chat and immediately sending photos, having requests, and they got me the models back, the first batch of models, in a day, and then some revisions on day 2. And through the whole process, I was able to then go and, hey, this is a little low poly, hey, this doesn't fit, hey, can you adjust this? And I was getting modifications immediately, and that is what we needed. So sitting here now, currently, Nikko Industries has the most accurate Herbie 3D model files out there because I was able to compare the model he was giving me back and be like, no, change this, tweak that, this isn't right, because I had the perfect reference. So if you're looking for the perfect Herbie file right now, it's Nikko's. And even after filming this video, there are a couple changes and upgrades I am gonna request he makes just to make it that much better. And based on the build I'm about to show you, they are made for Nikko's files where, yeah, you could go and integrate them into Dio3Ds or Yoshi's, but a lot of the brackets that we designed that I'm not sure if we're gonna release, we might put them in a Google Drive, they just would never fit. They'll only fit in Nikko's. So hope that makes sense. His is incredibly accurate and it's the one I'm recommending here. And also, I'm plugging him because this project would not have happened without him. So Nikko, thank you. If you're looking for good 3D files in general, go check out his website. If you're looking for the best Herbie file, well, here it is. Okay, so the plan was starting to come together. I had the 3D files from Nikko, I had my engineer, and when you're building a robot, what's the first step of building a robot? Danny.
Buy someone else's robot.
This is the Diablo Robot by Direct Drive. They sent this to me for a sponsorship like 2, maybe 3 years ago. Guess what I never did? But it was perfect for this project because, well, look at it. It's a fully self-controlled, little remote control, self-balancing gyroscopic robot that stands up on 2 wheels and can drive around. Literally perfect for this. So this was the base we were gonna actually make Herbie on. We just needed to get him printed and scaled properly to sit on top of it, kind of like the actual controllable animatronic in the movie, and this thing was absolutely perfect. So while planning this project out, like I said before, I was going to keep it simple, and had I not had Danny staying with me and working with me for this past month, I would have had no other choice. However, Danny was pretty confident that after we took a little trip to Walmart to look at like RC cars, we were gonna gut some electronics. He was pretty confident he could actually make this thing do all the things it mostly did in the movie.
I hoped.
Now, it was time to kind of divide and conquer. I knew I could get this thing printed as quick as possible. I was using every printer in my arsenal. Now, ideally, we would have liked to have printed this all in ABS or ASA or even PETG, but I had a lot of PLA left over for some other projects, so we just went with that. We knew it would hold up for what we needed to do, and I can post-process PLA very, very efficiently. So I took care of the printing and the post-processing. Danny was gonna handle the engineering aspects of it and explain why.
So one of the other advantages that we had when it came to printing this thing in PLA is, unfortunately, because of the absolutely insane timeline, we didn't actually have time to design all of the mechanisms the way we wanted to. Obviously, when you're designing a robot, you want to be designing the robot at the same time as all of the mechanisms, but we had no time to do any of that, so we just had to start printing. Thankfully, Nikko was able to leave us enough space within the actual shell of the robot for me to design all of the internals. Because of the fact that we couldn't modify the body, though, a lot of the approaches for how these things got assembled and modeled from the first steps just genuinely could have been a bit better, but they ended up working out at the end. In total, we pretty much split the custom design of the parts into 4 separate phases. We had the robot mount itself, so how Herbie was going to be sitting on this speedy little guy. We had the arm mechanisms, which at the time we weren't sure whether we were going to control each arm independently, have them attached together to lift up a tray, or anything else. So as far as it was designed, they ran on completely separate motors. Next, we had the whole head system. So basically the pan and the tilt, being able to have him not just look side to side, but up, down, all around, so that way he could make eye contact with everybody. Then finally, there were the eyes themselves and his teeth. Thankfully, from what we can see in the trailers, he's pretty animated for a robot that doesn't really ever actually talk. So we knew that we had to essentially approach this from 4 different spots, design 4 custom assemblies, and then make sure everything still somehow fit into this robot without modifying the actual robot in any way after we printed it. So that was pretty much the fun challenge that I had when it came to this project.
So before we move into the next part of the video, I do quickly want to touch on the post-processing, even though this is honestly the most boring part of the video. It's just white and blue paint, and I sanded some plastic. But hey, some people like watching me sand plastic, so I power sanded everything I could with like 80 to 220 grit sandpaper. Power tools go a long way. I hand sanded what I wasn't able to actually get, you know, the power sand, and then I moved on to the priming stage, and this Duplicolor red filler primer is still absolutely my favorite. I cleared out O'Reilly's and AutoZone again for this when we were trying to source materials, and I just soaked it in this paint. It worked perfectly. Once I was happy with the sanding and priming and the back and forth, and I had everything smooth, or at least the parts that needed to be smooth, I then moved on to a white primer to start really trying to look for any imperfections or spots I had time to touch up. Now, I went with a couple different whites here, over layered on top of each other. Initially, I was just using a normal primer white, but we ultimately went with a top coat of Duplicolor Pure White, I think it's called. It really can be any white you want, as long as it's not off-white. It's still gonna look good however you want to spray it, but this Duplicolor was just that final little top coat over the white primers and the white Rust-Oleums. Again, I was just using really what I had, and we were limited on time. I had also gone over everything with a satin clear coat. It wasn't supposed to be a high gloss. From the reference photos and everything, it needed to actually look like plastic. It wasn't meant to be some crazy metallic glossy Iron Man suit. So I hit everything with a nice satin coat, and it also made it a lot more manageable to handle and touch without having to risk any fingerprints or ruin anything. From there, I needed to make some of the white parts blue. A lot of the part separation was pretty good, which made painting very easy, but there were parts on the white main body that I did need to go and mask off. I was using yellow frog tape, and it adhered perfectly. It didn't ruin any of the white or any of the satin clear coat, but I just spent some time masking everything off. I probably used a lot more tape than I needed to, but once it was taped off, I moved on to a generic Duplicolor metallic blue. I believe this was a Chrysler blue. It's just a color we picked that we thought matched the Herbie robot colors as close as possible. Now, normally this would come out metallic or glossy, but since we were, again, going to go over it with a satin coat, it was going to dull that down a little bit, and I think it ended up coming out pretty good. Peeling the tape off of this was very cathartic. It is always just fun to peel those really nice lines after you spend time masking something off. You'll spend an hour masking it off and a couple seconds peeling it, but it is absolutely worth it. And while painting this thing, I also was working on the construction and assembly. I was trying to fuse together the parts that were going to be permanently fused together, like the lower body, but then I also needed to figure out ways to take it apart. So I was using heat inserts and M3, M4, and M5 bolts and nuts and screws to just try to design a way to attach everything and make everything come together, and this way we could also take it apart. So here I'm test fitting some of the parts that will absolutely be crucial that we need to be able to take off later to do the electronics. Now, I hope that all made sense. I know it was quick, but again, there really wasn't much to the painting and post-processing. Sand plastic, paint plastic, make plastic look pretty. So let's get back to the actual mechanical construction and what I think is really the most interesting part of this build. So here we are at the end of the design and printing process, and it's pretty much time to assemble the robot now. So we want to show you the final iterations of all the parts we landed on and basically put the robot together and show you how.
So going from bottom to top, we have the initial base bracket. Now this is one of the extra prototypes. We have this version on the actual robot, which was the final one. But to explain the construction for this, we decided to have it printed in 3 separate pieces to keep it as strong as possible. Pretty much each of these sections prints totally flat with no supports on the printer, so that way you don't have any binding against your actual layer lines where it could have snapped in case we moved the robot a little too fast or anything else. The whole point of this is to sit subducted up into the body of Herbie, where we have essentially just this long threaded rod with nuts melted into each of his silver side pucks on the side of his body. So once you put Herbie down onto the actual back bracket, you simply feed the bracket through, and then it's just a simple tighten fit on the other side. Now obviously there's some extra space here, but once Herbie's actually attached to this bracket, it holds him very, very snug on top of the robot.
So now moving on to the arms. This was a pretty tricky little thing to design. Now we had landed on making the arms just rotate up and down. Due to Nikko's design, we could position these arms and pose them in absolutely any position. We just have everything locked and super glued now to support the weight, but it is a completely articulated arm, which is fantastic. And I had decided to go with trying to support the weight of the arm using print in place planetary gears. So this is the puck that comes with the model by itself, 100% scale. I had gone and just grabbed some print in place planetary gears, scaled them down to fit perfectly inside of this. Initially, I was only going to use one, decided to use two. There's an inner one and an outer one, and they just lock in. And then we were also able to rescale these little puck arms to sit in there. This way, all of the weight of the arm isn't being forced down on the shaft of the servo. It actually distributes some of the weight, and everything just sits there and rotates perfectly. Now, since I had figured that out, it was up to Danny to figure out how to actually support the motors so they didn't go and torque and get all twisted.
So for that, once again, unfortunately, because of the timeline of this, I had to work entirely around the constraints of the existing model. So the first thing I had to do is figure out a way to be able to anchor down the servos. The first thing I did was design this base plate, which pretty much just sits exactly in the existing ribs for how this model currently assembles. So that way we're able to just bolt everything together. Once the entire chest piece is assembled from the front as well, it holds everything very snugly in place. And then we have plenty of screws in case we were worried about it not being held from there. Once everything from there has been assembled, it was pretty straightforward. It was simply just getting a matter of the spacings for the servos. The original inserts for the shoulders, or armpits, I guess I would say, looked like this, which work perfectly when it comes to a model that you're just going to pose and glue. However, we had to motorize it. So what I did is I simply modeled a solid version of this, took the negative of the attachment for the servo motors, so that way we could screw it all together. And then we get to the final assembly as you see in the actual robot. So as Frank said, the single most important part of this entire build was his neck system. Obviously, for Herbie to feel alive, we needed him to actually be able to make eye contact with the people he was rolling up to and really feel dynamic. So to start for that though, I decided to look into some other fictional robots. Specifically, the first thing that came to mind was WALL-E.
WALL-E.
There's tons of communities that already exist out there that build like droids from Star Wars as well as WALL-E. So thankfully there was a good amount of reference online for me to be able to go see just how different people designed their neck mechanisms. A ton of variation in it, but I found a very simplified one that I decided to use as my inspiration, which brought us to this. So down here we have most, but definitely not all of the different iterations when it came to this bracket. I am a firm believer of the best way to figure out the right way to design something is you have to design it wrong first. And thankfully 3D printing is the perfect technology to be doing that. So each version of these brackets slowly got beefier and beefier, it had better tolerances, it included compensation for other motors, for wires, being able to actually screw the servo motor to anchor it down to the assembly, and then finally I had to figure out how to connect each of these brackets back to the rest of the robot. So just like with the arm servos needing to be anchored down so that way the servos have something to torque against, I needed to figure out a way to anchor the entire head. By the time the whole thing was done, it was pretty heavy, so I couldn't simply just have it hot glued or anything else. It needed to be bolted. So I designed this pretty simple bracket to just sit over the existing arm assembly, fit under his head, and then the neck basically bolts in from here on the top. So pretty much the only actual 3D model when it comes to the external parts of Herbie that we were able to reprint a few times was the neck. When it came to actually fitting everything inside of it, I had to scale the neck up a bit, but thankfully I don't think it's that noticeable in the final design, and the actual bracket that houses the servo motor that spins left and right pretty much just got booleaned straight out, so that way there's some slight notches to help hold it in place. This entire assembly then got attached to a separate servo motor that gets bolted into here. This bracket sits in the base of his head, and then that's what controls the tilt and then the left and right. Obviously, this turned out very complicated and there's quite a lot going on in here. One of the biggest challenges as well is we had quite a bit of electronics that were going to be controlling all of the face motion, and I needed to make sure that we didn't get in the way of that, which is why I decided to have this bracket basically be free floating. So once we knew the final space needed for this assembly, we pretty much bolted this in where we could fit it, and then basically had the head balance from there, which allowed him to go left, right, and then up and down. Now, one of the other things that we had to worry about, as I said, was the weight of the entire system. Just like with the arms, we didn't want all of the weight simply on the main shaft of the servo motor. And after a brief conversation with our friend Kiara from Kiara's workshop, and some very passionate and colorful thoughts about how I approached the initial version of that bracket, we decided to modify it to also include a planetary gear, so that way all of the weight sat, instead of on the servo motors, on the weight of the rest of the assembly, down into the shaft, and then bolted into the rest of the body.
So Herbie's eyes, they move, they spin. He has these two little cute little teethers that move up and down. And I took this over from Danny because he had a lot going on with the arms and the neck. I wanted to figure out how to make this work. And as you guys know, I don't 3D model, but man, do I know where to find them. So what I did is I hopped online and I decided to find some DC motor mounts. You can get these, I believe these all were off Thingiverse now that I'm thinking about it, or maybe Thangs. I got DC motor mounts and I got these really cool linear actuators, but you can see them move up and down, and I just adjusted them to fit inside of this back plate and just cut this square back plate out of the back of Herbie's head. So getting everything mirrored, getting everything to fit, being able to position the DC motors, the shaft length all the way through, and then attach everything in the front was exactly how we got this to work. So now the little teeth can move up and down, or the lips, or whatever you want to call these, and we just position them in a way that didn't bind or didn't get in the way. As for the front of the face, this was a multi-layered stacked thing. Using my X-Tool P2, I think it's called, to actually go and cut this acrylic panel. This was just the little cherry on top, I think, of really bringing it to life, making it look just nice and finished, because he did have a nice acrylic or glass cover. But not only did I do the front cover, this back silver plate here is also an inlay that I cut and then vinyl wrapped with some silver vinyl that I had. And if you guys haven't noticed already, we did cut corners where we were able to. All of the eyes here, or the teeth or lips, these are all printed on an AMS system in a multicolor print orientation. So I was able to do the white, the black, and the silver all at once. It saved us having to mask and tape and print multiple things. And honestly, matching it up with the silver in the back, I think it looks pretty good, especially for some vinyl and some AMS multicolor prints. This worked perfectly. Once everything was printed, it was really just getting everything mounted, figuring out a way to mount the shaft to the back of the eye, making sure that the eyes weren't too close so there wasn't any friction while they spun. We did have to end up spacing this plate out. It's going to be pretty much impossible to see, but there's actually two nuts on the back of these bolts to actually space the plate away from the face, or else the acrylic is going to run into the eyes. They don't spin, nothing moves. But you can't really tell, and you wouldn't have noticed if I didn't point it out. At the end of the day, I'm really proud of this, especially for not really knowing how to 3D model and just throwing a bunch of assets together to getting it to work. I think this absolutely goes to show that there are different approaches, even if you don't know how to actually design from scratch and model in Fusion. I was able to put this together in Mesh Mixer, export it, do some testing, and pretty much what I printed is what fit, because other people had already done the testing and fitment for making sure that these actually fit DC motors and making sure that these actually were good linear actuators that took MG90 servos.
So with the mechanics figured out, now we had to figure out how to actually have everything working together. And by that, I mean we needed to figure out the actual electronics in this thing. Now, if you guys have been watching Frank's content for a while, servo motors are nothing new to you. Obviously, we've used them in Iron Man helmets to motorize things. However, this build presented some new challenges. The first issue was we could not just simply use an Arduino board, which is what we would usually be using with Crashworks kits and other components when it comes to Iron Man helmet builds and everything else, because we cannot be directly controlling this board, buttons or anything. We're not wearing this build, we have to control it remotely. To achieve that, we ended up going with an ESP32 board. These are designed specifically to be able to use Bluetooth connections, so that way you can control them wirelessly. This was actually a direct recommendation from our buddy Nick over at Plentiful Props 3D, as it's something that he's used in quite a few builds, and he was willing to give me some tips as far as getting them working initially. So we now had a board that allowed us to control the robot remotely, but we needed a way to actually give the robot inputs. So to do that, we use a PlayStation controller. The reason we decided to go with a PlayStation controller is because it was something we already had on hand, and we're able to get a ton of different inputs out of this thing. Between the triggers, the bumpers, the buttons, the D-pad, and especially the analog sticks, it allowed us to control the robot in a lot of very nuanced and refined ways, as opposed to simply having to build a custom controller ourselves. Now, being able to communicate wirelessly using a game controller to an ESP32 and then have that ESP32 control a ton of different motors is something I've never really done before. Thankfully, thankfully, there's a ton of great tutorials out there. Specifically, I used the tutorials from Rachel DeTorres's YouTube channel. I'm gonna have some links down below for that. It has every step that you guys need on how to do something at a bit of a smaller scale than we did when it comes to being able to control motors and servos with a PlayStation controller. So we have our ESP32, the brains of our operation here, but we needed a way to actually have this communicate directly with our motors. So the first component that we added is this DC driver board. This is what controls both of the eyes in the robot. Using this, we're able to have the ESP32 communicate directly with the two DC motors controlling the eyes. That way I can use one analog stick to control the movement of both eyes independently, left, right, up, and down, controlling each one slightly differently. Now, the fun thing that we found out was apparently not all servo motors are built the same. While we did a lot of initial testing using just MG90s and more small-scale servo motors, once you got to the beefier ones that we have in our H.E.R.B.I.E bot, unfortunately, some complications came up. What we discovered is certain servo motors on the beefier side need a 5-volt signal logic. For those of you that don't speak electronic, it basically means that our ESP32 board, while it might have worked with our smaller motors, could not communicate directly with all of our servo motors. And that was an issue because we had not yet ordered a servo driver because we didn't think that we would need it. Normally the board is able to power up to 8 motors on its own. However, we needed something that could communicate with them with a beefier signal. So what we ended up doing is placing an overnight order for a servo motor driver on Amazon. However, despite Amazon's wonderful one-day shipping guarantee that was on our order, it never actually arrived. And we ended up 2 days before leaving having to reorder from a different manufacturer and got incredibly lucky that the night before our flight, that board finally arrived. That board not arriving until the night before we left basically meant that we at no point were able to test all of the electronics simultaneously with the proper motors and actually assembled in the robot.
Okay, so that's pretty much H.E.R.B.I.E assembled-ish. This is the point where we hadn't really tested everything together as Danny was talking about, and we had to get them packed up because it was time to go to Open Source Live in San Francisco. So our time management kind of sucks, and it's not really our fault because they were, you know, the premiere was the weekend or the week after Open Source Live, which we were already slotted to go to. And it was an amazing time with some amazing people. And actually, if you guys want to stay tuned for the 3D printing nerd, actually came to our hotel room and did a little sneak peek of the light just died. Please hold.
Nice.
Hey, the light's back on. Anyway, as I was saying, 3D printing nerd came to our room and actually saw H.E.R.B.I.E, did a little behind the scenes thing. And you can see in that video, whenever he releases it, we were still working on this. We were still doing the cable management and the code and assembling it because we just didn't have time. We had to get it to San Francisco because we had to get it down to LA for the actual premiere. So I'm really excited to see that video. Joel and David, you guys are awesome, and thank you for coming to do that. So make sure you go check him out. So now with Open Source Live done, it was now time to move him from San Francisco down to LA for the big premiere. And it was the little guy's big day, but we just needed something a little extra. This was actually in part Danny's idea from the original promotional image of the Fantastic Four. You can see H.E.R.B.I.E over in the corner, just scooting around with a little martini glass and a little shaker. And we figured this would be adorable to drive around on the carpet and him just serving people drinks. And of course, he needs to have his best fit.
So with everything finally done, H.E.R.B.I.E fully assembled, it was time to actually get him down to the red, or I guess in this case, the blue carpet. When it came to actually getting him down there, we were thankfully actually able to drive him from the hotel all the way to the premiere, which is something we did not get to test at any point before this, because one thing I don't think we've mentioned quite yet in the video is we literally had to mail the battery for the Diablo Robot the day we started this project. In case you guys weren't aware, big batteries can't go on planes, so we couldn't check it, we couldn't carry on, so that thing had to get shipped via ground, which meant we shipped it the day we started this, and we had no way to know whether H.E.R.B.I.E would actually scoot around on that robot well until we were literally in the hotel room testing everything for the last second. So thankfully, when it came to actually putting the battery in the robot and getting everything finally assembled, everything worked pretty well. For the actual premiere itself, we were able to attend a few hours early while all of the celebrities were still getting ready and a lot of the fans were lining up outside, and we got some really cool footage kind of behind the scenes as they were still setting everything up for the premiere. I think one of the biggest compliments that both Frank and I would agree that we got is when we first rolled up with H.E.R.B.I.E onto the blue carpet in some of the press areas, we had a lot of the actual staff from Marvel who were working the event think that this was the production Herbie, which was really, really sick. It was a huge compliment to us. You know, obviously when it comes to any project, you are always going to be the worst critic of it. So just getting any sort of reception like that meant the absolute world to us. It was really cool. So after getting a bunch of really fun footage of him walking around with his martini, trying to find any of the cast to give it to, some nice shots on the blue carpet, some really, really great professional photos with the set, which was perfectly.
So good. He looked so good. And we realized that when we posted those photos on my Instagram, people just thought that that was the Herbie on the set, not the one we built.
People did not realize, and it was once again a great compliment, but we were like, oh God, okay, we need to clarify, we made this one. What worked out perfectly is we had no idea that there was going to be an actual professional photo shoot area at the premiere, which was recreating the poster that we were trying to recreate. It was the exact poster shot that had the tray, the martini, they had props and everything to go with it, and it was an absolute blast. It was super fun. We got to kind of help them set up with some of the photos and some of the early videos and everything, and it was an absolute blast. Herbie had a great time, we had a great time, and we couldn't have been happier with how he actually turned out at the end of it.
So guys, that's Herbie pretty much complete. One of my mics is acting weird, so we're gonna share, deal with it. This was an insane project on an insane timeline, and what we were able to get done, we're both incredibly proud of it. And I don't know, Danny, would you do it again?
I definitely would. I'm not gonna lie.
It was fun. Obviously, like we said before, there were compromises, things that some of you robot builders are probably cringing at. Oh my God, why did you do that?
Please don't judge us too hard.
We did our best. Honestly, leave some comments down below. Like, we really want to learn. Was there a solution for the neck? Was there a better way we could have done things? How would you guys have approached it?
The second thing that we want to make sure we plug is just the fact that a build like this, in this timeline, would not be possible without all of the friends that we have made over the past few years, just the community of knowledge out there, the modelers, the friends of ours that have personally worked on animatronics that are willing to give us input, the tutorials that are out there for how to do things like pairing up a PlayStation controller to control motors and everything else. This build would not have been possible without the entire community that backed us up to this point of working on it. So while we are very proud of the fact that this is something we made, it would not have been possible without everybody else in the community. So we want to say thank you to everyone else.
If you guys liked what you saw, please consider subscribing to the channel. If you want to see more Herbie, I don't know if there's going to be a V2, maybe not, depending on the comments, or all the 3D printing and content and cosplay stuff. So yeah, definitely subscribe and leave comments if you want to see more. If you have questions, comments, concerns, I read all of them and I will respond to as many as possible. And if you guys can do me one last favor, because you love this so much, please go check out CTK Creations on Instagram. I literally could not have done this without him. I just would have been a statue and it would have been way less entertaining. So definitely go check him out. He'll be linked down below, or if my editor put his hashtag and everything down here, I tag him in everything. You've seen him before. But yeah, that's going to do it for this video, guys. Thank you, everybody. Thank you, Danny and the Marvel team and Disney. And thank you guys so much for watching. You have a good day.